Just like in the previous video, we need to import the necessary art assets in our project. We'll need a background image for aesthetics, a ground object that our player can walk on, and a movable object, like the box that we have here. Now, modify their properties from the inspector window, similar to what we did in the previous video. Then, hit apply to save the changes. However, for our ground tile, we'll need to set its mesh type from tight to full rect, so we can extend its width properly in a few moments. Let us now add our assets into the scene. First, click and drag the background asset and a game object will automatically be created in the hierarchy. Then, reposition the background and scale it so that it covers the borders of the main camera. Place our tile object into the scene as well. If you will notice, you can't really see the ground asset in the scene because it is being rendered behind the background asset. To fix this, we'll just have to set the sprite's order in layer property to a higher value than the background asset. Now that the ground asset is visible, scale and reposition it to cover the lower part of the camera borders. In the sprite renderer component of the ground asset, change the draw mode from simple to tiled and modify its width property to extend the ground without distorting the texture. Lastly, we'll do the same process for our box asset. Drag and drop it in the scene view, then scale and reposition it to fit our game. Name our newly added asset something recognizable. Afterwards, add a box collider 2D component for the ground, crate, and player game objects. Make sure to edit the collider bounds so the collisions will work properly. Now, add a rigid body 2D component for the player and crate game objects so they would be affected by real-time physics. Make sure that the collision detection property is set to continuous and freeze the Z-rotation so the objects wouldn't rotate inappropriately. Now let's move on to scripting. Go to the scripts folder and open the script that we created last time for the character transitions. We're going to modify the code so our character can move around the scene. First, we'll create the rigid body variable and reference it in the start method. Then, we'll use the rigid body variable we created to access its velocity property. The velocity adds speed to the character so it can move. Make sure to add a public variable for the horizontal and vertical speed values of the character. We'll make it public so it can be changed through the inspector. We're also going to flip the character accordingly so it doesn't look like it's moonwalking. Take note that a positive speed value moves the character to the right, and a negative speed value moves it to the left. The getKey method of the input class will return true while the user keeps on pressing the specified key code. The scale value of X should depend on the game object's original scale, which in this case is 5. Now, we're going to create a ground tag for our ground asset. This is to allow the player to jump only when it is touching the ground. Set the ground game objects tag to the ground tag we just created. Then, let's get back to the script and program the jump function of the character. First, let's create a Boolean variable that becomes true if the player can jump. Set it to false since we don't want the character to jump the moment the game starts. Then, we'll utilize Unity's predefined method named onCollisionEnter2D, which runs every time our character enters another collider. Inside the method, we'll check if the collider contains the ground tag we previously created and set canJump to true. Now if the player presses on the jump button and the Boolean variable is true, then the player should jump using the addForce method of the rigid body class. We'll use force mode 2D.impulse so the jump would be instantaneous. Lastly, we'll set the canJump variable to false so the character cannot jump in mid-air. Save the script, and under the player game object, find the script component and modify the speed X and jump force properties. You can also modify this while in play mode, so hit play and adjust it however you see fit. As you can see, the character can now move and jump around the scene, and the real-time physics also works properly. Thank you for watching.